Hi guys, this is my second video on titration calculations and what to do if you have ratios in a balanced equation and how to use them. So if you want to start from the beginning, please see my first video on titration calculations, which I've included the link to in the description below. The question says a scientist needs to accurately find the concentration of some phosphoric acid. She finds that 35.10 centimeters cubed of the phosphoric acid was needed to neutralize 38.55 centimeters cubed of 0.05 moles per decimeter cubed sodium hydroxide. So remember, step one, we always write the balanced equation unless it's given to us. So we can see we're reacting acid plus alkali, so we write out the formula of these. And this gives us salt, so first bit of the alkali, last bit of the acid, plus water, and then we balance. Our second step, we have to work out moles. Notice we're given a volume and a concentration for the sodium hydroxide, which allows us to calculate moles of this. So concentration times volume, we have to convert our volume into decimeters cubed by divided by 1,000, and it gives us this value. So I've represented the number of moles in standard form or scientific notation. Then step three, we have to look at our balanced equation. We've just worked out the moles of sodium hydroxide, and we can see there's a big 3 in front, so we've got 3 times as much of this compared to this acid. So to get the moles of the acid, we divide the moles of sodium hydroxide by 3, because we've got a 3:1 ratio. So this number divided by 3 gives us 6.43 times 10 to the minus 4. So that is a smaller number than that one. Then our final step, we've got our moles of the acid now. We want to find out the concentration of the acid. So we can rearrange our moles equation in terms of concentration and do concentration equals moles over volume. So the moles of the acid over the volume of the acid, here it is 35.10 of the acid, divided by 1,000 to make our volume in decimeters cubed, and we come out with 0.018 moles per decimeter cubed.